All right, all you mathletes, we're looking at the last section in chapter 12. We're skipping 12.4. If you want to look at it on your own, you totally can, but you don't have to. And personally, if I had my professor tell me that, I don't think I would look at it. But, you know, it's there if you want to. So 12.5, we're going to look at Pascal's triangle. Now, Algebra 2 classes in high school, sometimes they go over this. And what it is it's just a quick way to expand out a binomial to any power. And if you can remember what this is, when you get into calculus, every once in a while, you're going to have to expand a quantity out like this. And it's really useful if you know Pascal's triangle, because if you don't, you're going to have to find another way to deal with it, and that's sometimes involves like creative factoring, depending on what it's used in, or you're going to just have to expand it out the long way. And doing that is a pain. So these quantities here, like we took x plus a and raised it to just different powers, just 0 through 5. And in general, it comes out like this. So if the a was an actual value, we'd have actual numbers in there along with just the x's. So if we looked at the coefficients, we can set up an actual triangle with just those numbers. And the coefficients themselves make a pattern. So we're not looking at, you know, the x's and the a's, it's just the coefficients, the 1, 5, 10, 10, 5, and 1. So if we took all of those coefficients and stacked them and arranged them like this, it makes a triangle. So there's a pattern that develops. Well, if you notice that the first number and the last number is always a 1, so if we wanted to get the next row, we could cheat and just look at this, or notice the pattern. So the pattern is you just add up the two numbers that are kind of above it. So 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, 4 and 1 is 5, and that's the last pair to add, so then it ends in a 1. So the next row starts with a 1, 1 and 5 is 6, 5 and 10 is 15, 10 and 10 is 20, 10 and 5 is 15, 5 and 1 is 6, that's the last pair, so it ends in a 1. So this triangle extends down forever and ever and ever. So you can look at this to try to help speed up this multiplication stuff out. All right, so let's give it a shot. So expand x plus 3 to the 5th. So what I do is I find the row that's going to go with x to the 5th. So this top one, that goes with the power of 0. So this would be power 1, power of 2, 3, 4, and that's the power of 5. So that's what we want to use. So I'm going to put these numbers out, the 1, 5, 10, 10, 5, and 1. And I'm going to leave some spaces in between because I got to figure out, well, what's connected to each one of those. So it's pretty simple. Just start with the first term, take the x, and you're going to raise it to the power that's on the outside. So raise it to the power of 5. So x to the 5th. Then you're going to decrease the power all the way down as you work your way this way, you know, to the left, or to the right. So x to the 4th, x to the 3rd, x squared, x to the 1st, and then x to the 0 or no x. Once you get that completed, then you're going to take the second term in the parentheses and you're going to do the same thing. Raise it to the power that's out here, but you're going to work your way backwards, work your way from right to left. So that would be 3 to the 5th, 3 to the 4th, 3 squared, 3 to the 3rd, then 3 squared, 3 to the first, and then no 3. And then after that, just work out the arithmetic for each term. So the first one is just x to the 5th. Second one, 5 times 3 is 15. Then we have 3 squared times 10, or 90. 3 to the third, 27 times 10, 270. 3 to the fourth, 81 times 5, 405. And 3 to the fifth, 243. And so that's a lot faster than trying to write this out 5 different times and foiling each set. So we're going to do this last one here. So the sixth, or the row that goes with the 6th power, which is this one, the 1, 6, 15, and so on. So the 1, 6, 15, 20, 15, 6, and 1. So leave yourself some room because you're going to have to start filling stuff in between them. All right, so we're going to take the 2x and raise it to the 6th power. And then work your way down the line, decreasing the power by 1 every single time. All right, now start with the second term. And the second term is -1. Don't forget to take the sign with that number or with whatever that is. So it's a -1, starting way back here on the right, and then work your way forward. And then no -1. All right, so now let's just do the arithmetic. So 2x to the 6th power, that would be 64 x to the 6th. 2x to the 5th power times 6 times a -1 is a -192 x to the 5th. 2x to the 4th times 15 times a -1 squared. So the negative cancels out. So that's going to be a positive 240 x to the 4th. And it's going to alternate in sign all the way down, because if you look at it, the negatives cancel out with the even powers and they stay with the odds. So now I have 2x to the 3rd times 20 times a negative. So 160 x to the 3rd plus 2x squared times 15 times 1 would be 60. Then 2x times 6 times a -1, -12. And then -1 to the 6th is a +1. So that is a gigantic polynomial, but a lot faster than trying to FOIL it out individually. All right, so that's going to do it for this section. It's kind of short, and that's going to do it for the chapter as well. So let me know if you have any questions. Please try the homework, do the worksheets, look over your notes, and send any questions my way.